Okay, so we're going to keep talking about our exponent rules. So if you recall from last time, we did the product rule and the power rules. So today, we want to introduce the idea of what it means to be a zero exponent. Anytime your exponent is zero, your answer is 1, right? Anything to the zero power is 1. Now, with that being said, once again, be careful about something like this. If it was just -3 to the zero power, that exponent has nothing to do with that negative unless it's on parentheses, so this would be -1. Anything to the zero power is 1. Negative exponents, if your exponent is negative, negative exponents have nothing to do with negative numbers. Negative exponents have nothing to do with negative numbers. Negative exponents mean reciprocals, right? Look at this example they have over here. Your final answer is not a negative number, it's a fractional number. Negative exponents have nothing to do with negative numbers. Okay, so if you have a negative exponent, basically it means use your reciprocal, which means you flip your fraction upside down. So if it's not a fraction, you can put it over 1, and then if you flip it, that's how you get your exponent positive. This is the same thing down here, right? If you have a negative exponent, you can flip everything. It makes your exponent positive. Okay, if this is negative, if you move it to the bottom, it's positive. If this one's negative, it moves to the top, it's positive. To make a negative exponent positive, you simply change its place from numerator to denominator or denominator to numerator. And it applies only to the one thing it's on. And then we're going to have the quotient rule. The quotient rule, like the product rule, except the only difference is you subtract the exponents. Right? You subtract the exponents instead of adding them. Because basically, if we had, let's say, x squared over, let's make this x to the 5th, over x squared, remember what that means, 5 x's on top, 2 x's on bottom, and look, these that's the same can divide out, and you're left with 5 minus 2, or 3 x's. Okay, so we're going to practice those rules. Okay, anything to the zero power is 1. Anything to the zero power is 1. Anything to the zero power is 1. This is not all to the zero power, though, so be careful about that. This is -1 because this exponent has nothing to do with that negative. If it did, it would be in parentheses like this one. Now this whole -7 is being raised to the zero power. But here only the 7 is being raised to the zero power, so the negative stays. All right, now here I've got a plus sign. So the only thing I can do is evaluate each one individually. Anything to the zero power is 1. Anything to the zero power is 1. 1 plus 1 is 2. Okay. Negative exponents mean reciprocals. Negative exponents have nothing to do with negative numbers. Negative exponents have nothing to do with negative numbers. So to get rid of a negative exponent, all you do is change its position in the fraction. And then, and only then, when it's positive, then you can evaluate it. You cannot evaluate a numeral when it has a negative exponent on it. Negative exponents mean reciprocals. So you flip the fraction and it makes it positive. Notice this negative is on the parentheses, so it means flip everything inside the parentheses. This exponent is applied to everything inside the parentheses. And now 4 over 1 is just 4, so we wind up with 4 cubed, which is 4 times 4 is 16 times 4, 64. Notice, not a negative number. Not a negative number. Okay, this is the same thing. The negative exponent is on parentheses. That means everything inside the parentheses must flip upside down, and that makes that exponent positive. Now, once it's positive, now I can apply it to everything inside the parentheses. 5 times 5, 25. 3 times 3, 9. Okay. Negative exponents mean reciprocals. So remember, this is like this if I need to see the fraction. And so I'm going to flip it upside down and make that technically a positive one. And then a positive 5. A positive 1 on the 5. Okay. But now, this is just adding two fractions. So to add fractions, I need a common denominator, which is going to be 10. Come on, pen. All right, so I've got to multiply this numerator and denominator by 5, this numerator and denominator by 2, so that I have the fraction 5/10, which is the same thing as 1/2, right? Plus 2/10. Once the denominator's the same, it stays the same, and you add numerators. Okay, those plus signs and minus signs between values, I do not have any rules to simplify that. I just got to handle each one individually and then finish the problem while adding or subtracting. Okay, negative exponents mean reciprocals. Negative exponents mean reciprocals. Simple as that. Okay, more practice. Okay, so the 5 has a negative exponent. To make it a positive exponent, you change its place in the fraction. Okay, if this 3 did not have a negative exponent, I would not move it. You only move the one that has a negative exponent. A lot of times people see something with a negative exponent and they just flip everything. No, I'm only moving this to the top because it also has a negative exponent. Now, when they have positive exponents, now and only now, I can evaluate it. So 3 times 3 is 9, times 3 is 27, and 5 times 5, 25. Okay, so first thing, I'm going to get rid of those negative exponents because I cannot work on my problem with negative exponents. The only thing that moves are the ones with negative exponents, and you move them to make it a positive exponent. This 4 has an exponent of positive 1, but the h has a negative exponent. Since it's in the numerator, move it to the denominator. The m has a negative exponent, so since it's in the denominator, move it to the numerator. That's what makes the exponents positive. The k has a positive 1. Don't move it. Its exponent is already positive. Okay, and now when I look at this, there's nothing left to do. I've got one number with no math operations on it, one m, one h, one k, no negative exponents, no parentheses. That was all it needed. Okay, inside parentheses, there's nothing to do, right? Inside parentheses, there's nothing to do. So if I want to make this a positive exponent, it means everything inside the parentheses has to flip. Since it's on the parentheses, it applies to everything, and that makes that positive. Now I've got to get rid of the parentheses. So this is 2 to the third. It's going to go to everything inside the parentheses. And when I have an exponent raised to an exponent, you multiply. So 3 times 3 is 9. Okay, an exponent raised to an exponent, you multiply. 2 times 3 is 6. Now, I'm not finished this time because here's some math I can do, right? 2 times 2 is 4, times 2 is 8. But there's only one value of a y and one with an x, and none of them have negative exponents, and I've gotten rid of the parentheses. So I know there's nothing left I can do. Okay, These we said earlier, remember, they should not give you a 4 to the 7th to evaluate, right? But you are going to have some like this, because that tells us, oh, I can use my rules for exponent. Now, I could find out what 4 times 4 times 4 times 4 times 4 times 4 times 4 is, and then do 4 times 4 times 4 times 4 times 4, and then simplify that number. But oh my word, I love math, and I don't even want to do that. So instead, we want to recognize, hey, they've got the same base. I can use my exponent properties to make this simpler. If there's 7 4s on the top and 5 4s on the bottom, 5 of those are going to get to divide out and just leave 2 4s on the top. Notice that's my rule. Set for quotients, 7 minus 5 is 2. But if I just kind of think about what's going on with that, it's really beneficial. Because look at this. If I used my rule and said 5 minus 7, I'm going to get negative 2. So I would have a 4 to the negative 2, and then I got to get rid of the negative exponent. But instead, if I just think about what does that mean if I have a fraction with common factors in the numerator and denominator, however many are all the same can divide out. So I'm going to get to cancel 5 of these 4. The only difference between this problem and this one is this time the extra ones are going to be left in the denominator, right? Basically, we could think of that like that. And remember, it's not a 0 when everything gets divided out, it's a 1. Now that's the same thing we would have gotten if we'd have made this 4 to the negative 2. Then I'd say, oh, a negative exponent has to trade places. But instead, I'm just going to think about what that means. It saves me a little work most of the time. Anytime we have negative exponents, we got to get rid of the negative exponents first. So, well, we don't got to, but that's what I do, right? So, because this is a negative exponent, to make it positive, it's going to go in the denominator. This one is also negative, so to make it positive, it's going to go in the numerator. And now I realize I've got a bunch of x's on top, 12 to be exact, and 6 on the bottom. So 6 of those are going to cancel out, and there's going to be 6 x's left up on top. Or if you want to use your rule, 12 minus 6 is 6. All right, so negative exponents I'm going to deal with first. The 4 does not move. It does not have a negative exponent. Only the value with the exponent sitting on directly on it will move. And there's no more simplifying that can be done there. Okay. There's 4 8s on top and 5 8s on bottom. 4 of them will cancel out and leave 1 8 on the bottom. Right? There's 9 m's on the top and 10 on the bottom. So how many is going to be left? And where is it going to be left at? Yeah, there's more on the bottom, so the leftovers are going to stay on the bottom. Now this has to move to the bottom to make it positive. If there's nothing left in the top, there's always a 1. I know I'm not finished because I have these two that have the same base, so I can combine those. And whenever you're multiplying exponentials with the same base, remember what it means. Oh, here's 3 n's multiplied together times 2 more n's. So I'm going to add that 3 and the 2 to get an exponent of 5. Okay. So this one, first of all, let's get rid of these parentheses. An exponent raised to an exponent means you multiply. Now that one I just kind of have to remember what that rule is. It's not as easy to see as my rule and quotient rule where I can just think about what it means. 4 times 2 is 8. Okay, there's nothing happening on the bottom. But now I've got two numbers with the same base. Again, if there's 8 3s up on the top and 3 of them on the bottom, I'm going to get to cancel out 3. If I wrote it out 3, 3, 3, 3, 3, and 3, 3, 3, 3 of them would get to cancel out. So how many would be left? And they would be left on the top. So I don't have to put this. I can. It's going to count it wrong on your homework if you do, because it's not simplified. But if it helps your thought process, it's on the top, obviously. But now 3 to the 5th, I've got to figure out what that means. And 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. Okay, first of all, there's nothing inside the parentheses to do. This one, there's no reason that's even in parentheses. But this one, this 2 has to go on that 4 and on that X to get rid of the parentheses. Okay, now you can either make this 16 right now and do 16 times 4, or you can think of this as, oh, that's exponent of 1. They've got the same base. That's 4 cubed. And then x squared times x squared. Here's 2 x's times 2 more x's. Altogether, that's 4 x's being multiplied together. And either, again, 16 times 4, you get 64, or 4 cubed. 64. Okay. Nothing inside parentheses to do. I always look inside parentheses, and then second step always, negative exponents. Okay, nothing inside parentheses to do, negative exponent. Because that exponent's sitting on a parenthesis, everything inside the parenthesis has to flip. That's what makes the exponent positive. Now, to get rid of the parentheses, that exponent of 2 has to go on every single thing inside the parentheses. And because this already has an exponent of 2, 2 times 2 is 4. An exponent raised to an exponent, you multiply. 6 squared is 36. 5 squared is 25. And then y to the 4th we've already taken care of. Okay, inside the parentheses, there's nothing to do. Let's take care of negative exponents. 3 to the 9 does not have a negative exponent. This all has a negative exponent. This negative exponent goes to that whole thing. So it moves to the denominator to make that exponent positive. All right, so I've gone all the way across the top. That's going to stay on the bottom, but that's going to move to the top, and that stays on the bottom. Only the ones with the negative exponents move. Now, let's get rid of these parentheses. 3 to the 9th, x to the 4th. I'm not working with any of that. Okay, 2 times 2 is 4. Y squared is y squared. And then I'm not working with any of this. Okay. Here's a like term. All right. So if there's 9 on top and 3 on bottom, there's going to be 6 left on top. Okay. Now I'm going to work with the x's. Oh, look, anything divided by itself, I can just, all 4 of those x's are going to get canceled out. So now let's do the y's, and they're both in the same place. So if there's 2 y's times 1 more y, then really on the bottom, there's 3 y's. Okay, now that's a bit much, but we already know that 3 to the 5th is 243. So if we just multiplied that by one more 3, we have 729 over y cubed. All right, one more. Let's look at this one. What do you think you're going to do first? Yes, because there's nothing inside the parentheses. Let's get rid of negative exponents. So this 8r to the 4th is going to stay on top, but this is going to be 8r cubed in the denominator now. And this is going to be 8r to the 8th in the numerator. And this is going to be 8r to the 10th staying in the denominator. Okay, now notice on this one, I could get rid of those parentheses and make this 8 to the 4th, r to the 4th, 8 to the 8th, and then work them individually. But really, right now, they all have the same base. It's all 8r to the 4th, 8r, right? So it doesn't matter if that's a big giant X. I can use my rules on this entire base. So on the top, there's 4 of these things times 8 more. So altogether, there's 12 of those 8r things. And then in the bottom, there's 3 and 10. So there's 13 of those 8r things. Now, there's 12 of them on the top in the numerator, 13 on the bottom in the denominator. So 12 of them will cancel out, and there will be one 8r left in the denominator. Yeah, sweet, right? Okay. All right, let me know if you need anything.